Hello and welcome to a video in which I'm going to explain differentiation rules. In particular, I'm going to explain the chain rule. So you all have the differentiation rules available in the formula booklet. Let's take a quick look at them. Here they are. Now, you're probably all very familiar with all of them except for the chain rule. So let's take a quick look at it. Here's the chain rule. And before we move on, let's just remember this crazy notation I have in the formula booklet, which seems really uphill. This du over dx. What does that mean again? Well, remember the product and the quotient rule. That's saying dv over dx, the same thing as saying v prime, which you're all a bit more familiar with. So, if I have the quotient rule, I could have just written it like this. Now, it's absolutely perfectly fine notation both ways. Just remember that they kind of like the dy over dx, dv over dx type of notation. So, before we move on to explain the chain rule that we had in the formula booklet, let's take a quick revision of composite functions, because this is the fundamental part that you are going to need. So consider we have f of x equals sine squared of x. Now that means, remember that we put the square in between the sine symbol and the x symbol. It's just a way to make sure that we understand that it's the whole of the sine x that's squared. So that thing on the left is exactly the same thing as this thing here on the right. Now, we can define this as composite functions. We can say that, well, one of them is going to be x squared and the other one is going to be sine of x, and the only thing I'm going to do is define f of x as putting sine of x inside of x squared. Do you remember this? It's very important that you stop for a minute, pause the video if necessary, and remember how to just put this thing inside of this thing here, and that's how you can get that's how composite functions work. So this is really important to be able to continue making derivatives. You must understand and feel okay using composite functions and figuring out where the composite functions are. So this is a little practice. Pause the video if you want to. Just try to breaking up the following into composite functions. It's very helpful. So the chain rule. Now let's get to it. Here's my function again, sine squared of x. And I know how to divide it into composite functions. There you go. We're going to call u of x the outside function, because you see here is on the outside, right? F of x equals to u, open parenthesis, v of x, close parenthesis. So we call v of x the inside function. So to calculate the derivative of sine squared of x, what we do is we make the derivative of the outside function without changing the inside one. So I'm just going to make the derivative as if this whole sine of x thing was just one big x. And then I'm going to multiply by the derivative of the inside function. Let's do it. So here I have sine squared of x. I'm going to calculate f prime of x. There you go. So 2 times sine of x, if you think about it, is the derivative of x squared. But instead of x, I wrote sine of x. And I multiply times cos x, because that's the derivative of the inside function of sine of x. Now that's very much how it works. It's all as simple as that. Let's make some examples here. So natural logarithm of x squared. Well, it will be 1 over x squared, because that's the derivative of the natural logarithm, is 1 over, but instead of x I have x squared, times 2x, which is the derivative of what's inside. Simplify and I get that. How about this one here? Well, it'll simply be cosine of 5x, which is the derivative of this thing here, times 5, which is the derivative of the inside function. If f of x equals to 3x minus 2 to the power of 3, well, it'll be 3 times 3x minus 2 to the power of 2, which is the outside function, times 3, which is the derivative of the inside part of the 3x minus 2. And finally, if I have e to the power of 5x, it'll simply be e to the power of 5x times, and now the inside function is 5x, so times 5. And that's how it works. The important thing here to realize that derivatives require lots of practice, so you will be getting some worksheets on this. But I hope this is helpful, and after you know how to use the chain rule and the rules that you have there, you can pretty much differentiate any function. Thank you for watching. Goodbye.